in the earlier class, we saw what do we mean by matrices. Okay, and we also, there's one very introductory I was giving. Okay, so how do we define a multiplication rule, and then eventually we have to get to the whole algebra of matrices and all. So and there's a formal definition of a matrix. So if you remember, what we wrote is something like this, right? So we had something like A, B, C, D. Okay, or otherwise we had x1, y1. I can keep writing like this. I can even have something like A, B, C, D, E, F, G, H. I can do that, right? Because it means what? This means if I call it as xy, how many points? 1, 2, 3, 4. If there are 4 points, sir, if I want to represent 4 points, then A, E, B, F, C, G, and D, H. Correct? So this way I can write. So basically, so this all this combinedly, I'm going to call them as a matrix. So then what happens? So that we can form a definition. So matrix is nothing but a kind of a rectangular arrangement of numbers. Correct? So what they given the definition in your book is a rectangular arrangement of mn numbers, where in m rows and n columns. So here what happened? 2 rows. How many columns? 1, 2, 3, 4. So here we are represented 2 rows and 4 columns. Here we represented 2 rows and 2 columns. Here we represented 2 rows and 1 column. So basically a group of numbers were represented by some say call it as m rows and n columns. Okay, and that representation is called as your matrix. So that was the definition of matrix. We saw it in the earlier class itself. Okay, and then there is then there are types of matrices. You can see here itself. They all are different types. Am I right? So then you can define the types of matrices. The first simpler type is this one. So that is what? So here you see there is only one column, okay, but there are many rows. So we call this matrix as, so this matrix you call it as a column matrix. Okay, so column matrix is what? It has only one column and many rows. For example, if you use a Cartesian coordinate, what we are using Cartesian is only x and y, correct? In a 2 dimension. If you have 3 dimension, you'll have x, y, and z, correct? So in that case, what happened? x1, y1, and z1. If you have multi-dimensional, if you have some other problem where you're having large group of numbers, then it's going to be a longer and longer one. Okay, so these types of matrices are called as your column matrix. Same way, I can represent this as x1, y1 or x1, y1, z1. Okay, so like this I can do. So when I represent them as a row, you call them as row matrix. Now the question comes, when I'm able to see, all I have to do is I have to represent 2 numbers, correct? I'm representing as a row. Why should I represent like this also? You should ask the question, now why do I need a row matrix? I can always define as a column matrix. You got it? Because if you remember that last class we saw, right? So we draw a coordinate system, okay, and we had a point which is x comma y, and we were representing this point as this way, correct? Why should when I represent, this is also basically same. Correct. Why should I have this representation also? And that's a very interesting thing. If you remember, in last class we put a multiplication rule. Remember, a point, sometimes a group of numbers. Sometimes a group of numbers, when it combine, it will give you a single number. For example, I can say a very simple example here. And if you remember, we wrote it as a vector, right? So if I ask you, what is the length? Got it? I have given a number. I have given a, so this is xy. Xy is a matrix. But this matrix will have a length L. There is a number. You got it? So so now given this representation of matrix x1, y1, how will I measure what? So I represent this point as x1, y1. Now I am asking, can you tell me what is the length from the distance from the origin? So then you have to define, you have to use that because we need the length also for some calculations, correct? So how we are going to do is, then I will make a row matrix of it. So we remove what happened? So we made it as a x1, y1, okay, and then I will create a row matrix of it. Row matrix what come and this becomes x1, y1, correct? Then multiply this row matrix with the column matrix. So then it makes x1, y1. Now you know the multiplication rule. You remember that? So first row, first column. So this into this plus this into this. Is there any other row column is left over? So what will you have? You tell me. So you will have x1 into x1, x1 square plus y1 into y1 makes it y1 square. Correct? So what is that? x1 square plus y1 square. The distance. L equal to what? Square root of x1 square plus y1 square. Correct? So this makes it L square. You got it? So basically even though a point I can represent as a column matrix, sometimes to get a number out of this matrix, I should always have a row representation also. The moment I make a row representation, I can just multiply these two and we can do it. We can get a length of it. Okay, this is one simple example. It's not just always the same one. If I have some other, I think maybe in your physics class you will find it out. So if you have another number also, so that is this is x1, y1, right? So you have another point x2, y2. Okay, and if you actually see, if I do it like this, x1, y1 and x2, y2. Okay, this also give a number, correct? But they are not the same points. So when you do this, you will see it can be used to find out the angle theta between, cos of the angle theta between them. Cos theta. So this will give an idea of what is the angle between the two vectors. Okay, so these things you will learn it later on. We are not going to do one. So basically what I want to say, therefore a matrix, like for example here in this case we saw a vector can be represented as a column matrix. Okay, and that is not sufficient. I should be allowed to express the same thing in the form of a row also. Okay, then only I can combine these two quantities and get some number. And the number like, for example, length. Right? So therefore, matrix, in my simple matrix, I have two definitions. One is your column matrix, another one is a row matrix, right? So the first one type is what? So let me use a different color. First one is row matrix. Row matrix has only a row. Okay, and then second one is column matrix. What is the example of row matrix we said? We can write this one as, say something like x1, tell me, what's the way you go? Give me example, x1, y1, z1, these are the example. Column matrix is, oh, sorry, there should be no comma, sorry, I made a mistake. It's not a point, it's a matrix representation. Okay, so x1, y1 it is, y1, z1. Okay, and this is the row matrix and column matrix. As I told you, suppose if you see, sometimes what happens when you are writing this matrix form, okay, so there can be many numbers, right? So if you write x, y, z, now it still has numbers, then you really struggle for what are the alphabets I will use, correct? So that's what the usual way they write it is, it's a very easy way of writing a matrix is, suppose for example, any matrix. I told matrix will be defined as a capital letter. So what they write is A11, A12, A13. Okay. And then, so last number will be what? Suppose if it has M. So this will be A1M. M columns. Okay, so let me read N columns. A1N. Okay. Second will be A21, A22, A23. It goes up to A2N.
Like that A and 1.
Yeah. So then A?
And 1.
No.
3 1.
Correct. A31, A32, A33. Go on like that, A3N. So each A is different numbers. Okay, so otherwise I don't, here if I write X, Y, Z, I'll have a shortage of alphabets, correct? So here if I do it, I can write whatever number I want. So then you keep on doing that. Let me make this bracket longer. So suppose if there are N rows, so then it becomes AN1, AN2, AN3. It's go on, the last one will be MN. Okay. And yes, this definition I should have told you that. I forgot to tell you. So when you have this, so then this each value, you call it as an element. Okay. So each value is called as this is an element. This is an element. Okay. And you can always, this way of representing why it's easy is, this index will tell you where that element is. You got it? Suppose I am going to write okay, A of 2, 3. You can clearly say that is second row, third column. So this value corresponds to here. You got it? 5, or you can say N, 3 or N, 2. That means nth row and second. Okay, and not only that, fine, yeah. So this is the, okay, so in general what they write it is, you can write it as A of ij. Okay, it means what? Ith row and jth column. So this is just to make you easy to recognize the values, which value you are speaking about. There's nothing like some hard or something. You can use whatever you want. If you don't like this whole thing, and then you can use your own definition, but nobody will understand what you are speaking. Okay. Okay. So this is a terminology worldwide people are following universally. So we have to stick to that. And then what happened? Yeah, the other definition is, okay, yeah, example. So this matrix, so what we call, so how many rows this has? N rows. Correct? 1, 2, 3, up to N rows. How many columns it has? Oh, sorry. What I done? Oh, I made a mistake, right? Oh, sorry. This is M. Huh? Oh, yeah. Oh, okay. You should have corrected me there itself, na? This is M1, M2, M3, going up to Mn. Correct? So, yeah. Basically, so how many rows we are having? M. How many columns we are having? N. Okay, so then you call this matrix A as, so this matrix is called as your, this is your M cross N matrix. You got it? So row matrix, say for example, what will be the, what is the order of, this is the order of the matrix. Okay, say M cross N matrix. So this will be? How many rows? So 1. How many columns?
3 columns.
3 columns. 1 cross 3 matrix. That's it, na? So this is the number of rows. The rows multiplied by the columns. And so this one, this will be?
3 into 1.
3, it's not into. 3 cross. Okay, 3 cross 1. Okay, so similarly you can find out. So if I write 2, 3, 5, 4, 6, 7. So what will be the rank of this matrix? Rank name. So what is the order of this matrix? I made a mistake here.
2 cross 3.
Yes, it's 2 cross 3 matrix. In your book, they have said it is not cross, by. They call it 1 by 3 matrix, 3 by 1 matrix, 2 by 3 matrix. Okay.
That's the square columns, like fold to fold, those ones.
4 by 4.
4 by 4.
Correct.
Yes.
4 by 4 you call, and they use the same way. With the one. Okay, anyway, we use 2 cross 3 or something. Anyway, it doesn't matter. So basically what happened, that's the way you call it. What important is whether you will be able to use these techniques to solve the real problems. That's fine. Okay, so you can maintain the same name by 1 by 3, 3 by 1, this sort of matrix you can do. So now you understood why we need a row matrix and why we need a column matrix. That also understood, and you also see what is a typical, how do you are going to define a matrix A and how the elements are being written. Okay, not just that. So then we know what is the what you call the order of the matrix, m cross n and all. Okay, so correct. So yeah, that's it they have, and typically what they say is I use A if I call my matrix as A. If I call it matrix as B, then I'll write it as B. You got it, nah? See, something like B, if the matrix is B, then I write what? B of 1, 1, B of 1, 2, B of 1, 3, B of 2, 1, B of 2, 2, B of 2, 3. It go on like that. Okay? Huh? So remember that. And if you there's one more thing I should have told you. So A of II means what? If I equal to 1, then becomes A of 1, 1. I equal to 2, A of 2, 2. Okay? Yes. So this is what you call the diagonal elements. This is called as the diagonal elements. So that representation is A of II. If you don't like IA, put A of JJ. So whatever. Here also. B of, if I write JJ. Okay, they all represent the diagonal element. Okay, so these are all important. Means this will be very useful when you are working on some problems. Okay, and fine. So this is two simple matrix. First we defined row matrix and a column matrix. And the next important matrix is something what we call a square matrix. What do you mean by square matrix?
The rows and columns will be equal.
Yes, simple. It's a square, right? Yeah. The definition that itself will give you the name itself will give you what it is, right? So when you have an equal number of rows and columns, then you call that as a square matrix. Example we had, right? We saw many examples, correct? So a simple example is that for earlier class itself we saw A, B, C, D, 2 rows, 2 columns. Okay, so this is a 2 by 2. I shouldn't call cross now. In your book they have by 2 by 2 matrix. That's the order of this matrix, and so this is a square matrix. So in general, so it will be n cross n. Means same. So this will be 1 cross n. Correct? This will be n cross 1. Okay, so n can be any numbers. 1, 2, 3. For the example we saw n was 3. Right? So this is a way a square matrix is defined, and the next one comes as your that's pardon?
Rectangle like m into n.
That's a rectangular matrix is a common. A matrix is a rectangular arrangement. See, the moment when you call a matrix, that itself is a rectangular arrangement. So we don't have to call rectangular matrix. You got it? Rectangular arrangement is the matrix. We don't have to define it. You got it? So there's no need for that, because that's what we define the matrix. Matrix itself is a rectangular arrangement of numbers. And how we are arranging the numbers, if you arrange it in a row, then we call it as a row matrix. If you arrange them in a column, then we call it a column matrix. If they are arranged in as a square, then we call it a square matrix. And there's another one matrix is called as your, this is required null matrix, or they call zero matrix. what it is, all elements, if the all elements are 0, you'll ask, why on the hell I need such a matrix? You got it. So there are times you will get it. Okay, so, and I'll tell you. Okay, you will see that. So suppose if you have a matrix with 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so, and so this such a matrix is called as your null matrix. Okay, why do we need it? We will see for the completeness. So what happened? Null matrix definition is any element A of ij is equal to 0 for all I and all j. That means all elements are 0. Okay, why do we need this? Suppose, why? See, matrix equation when we write, we have to match exactly the matrix equation, right? So you will see later on addition of matrices. When you have matrix, so suppose if I call a matrix A, B, C, D. Okay, or I'll have one more element. Yeah, I'll have one more. A, B, C, D, E, F. Why I'm always using a square matrix? Now I am asking, what is A minus A? Okay, when we define this addition, what happened? With addition subtraction means when I add up, when I have two matrices, suppose for example I have another matrix B, let me call it as X, or I'm running out of, see, that's what we use this symbol. You got it, nah? So this will be what? A11, A12, A13, A21, A22, A23. Correct? So when you have this form, it's easier to write for us. So then B11, B12, B13, B21, B22, B23. So we will see, so if you remember, we defined the multiplication, right? What an addition of a matrix is. Addition of a matrix is, suppose matrix A plus matrix B, how do we write it is, that is A of 1, 1, A of 1, 2, A of 1, 3. I'm not following as your book. I'm jumping all ahead and forward. Okay, so I'm connecting all of them. So then this is A21, A22, A23 plus, what was this? B11, B12, B13, B21, B22, B23. So when I add them both, what it becomes is add element by element, individual element. So that means A11 plus B11, A12 plus B12, A13 plus B13. Similarly, A21 plus B21, A22 plus B22, A23 plus B23. So this is the way a matrix is addition. This itself says, if your order of A and B are different, can you add? You can't. Okay, for matrix addition, always that we will see later on algebra. When I go detail, I'll explain you. It demands always the order of matrix will be same. Then only you can add. So those things are okay. That is okay. Suppose I am asking. So one of the important property of this matrix addition is, if you see, the order remains same. Am I right? This is what? 2 cross 3. This is also 2 cross 3. When I am adding a matrix with 2 cross 3 with 2 cross 3, we should get what? 2 cross 3 matrix. This is also 2 cross 3. Now I am asking you to do this one. What is A minus A? Tell me. Yeah, you can write 0. Because I said the order has to be maintained. Am I right? So in that case, it is going to become, so this will be a 0. So this will be A of 1, 2, A1, A11, A12, A13, A21, A22, A23. Okay, and what?
Minus A1.
Actually, I made a mistake. When I say diagonal element, this usually comes when you are square matrix only. Okay, it comes only m equal to n. Okay, otherwise it won't come. We will see that when you have a square matrix, we will see that. Yeah, we said na. Okay, otherwise this diagonal element will not come. Square matrix is a very common matrix. What you will see, square matrix and column and row matrix usually. And this will be minus, right? So this is minus again A11, A12, A13, A21, A22, A23. So this I can't write it as 0. You got it? Because order has to be maintained, right? So all I have to do is, even though it looks very boring, but still I have to write it 0, 0, 0, 0, 0, 0. Okay. So then I have to define some matrix where all the elements, and this can be different. Sometimes there can be 2 cross 2 matrix, 2 cross 2 null matrix. And 2 cross 2 null matrix is not same as 2 cross 3 null matrix. You understand? So that's what your null matrix is also important, where all the elements are 0. Understood clearly now? So that is the other definition, other type of matrix, that is your null matrix. So anyway, I already introduced most of your matrix algebra in this here itself. Okay, and anyway, we will see it more detail in when we go to the next class. We will see more about the matrix algebra. Okay. So anyway, since I just introduced you all these things, so it make you easy when you are going to matrix algebra. And then there is something called as, okay, actually they both are connected. So then the fifth one is, it is connected to square matrix. That is fifth one, that you call as a diagonal matrix. Okay, what's a diagonal matrix? Okay, so diagonal matrix is what? And so, because diagonal matrix happens only for square matrix, there only diagonal elements will come. Okay, otherwise means your rows and columns will not match. You can't write like a diagonal. So the diagonal elements, I mean. So diagonal matrix is what? A matrix where all elements are 0 except the diagonal elements. Okay, how do we write it? So very nice. Actually, this notation when you write, it makes very easier to define all those things. Diagonal matrix is the one where A of ij is equal to 0 when I is not equal to j.
Why I is not equal?
Oops, sorry. When I is not equal to j. Clear? Are you able to follow these notations and all? If you have any doubt, if you practice more and more, you will understand these notations. See, that's what, see, the totally we are doing into a different type of mathematics. Can you see? Can you follow that? So this is a diagonal matrix. In representation, how do you will see? So that means, for example, you have A11, all the elements are 0. So for example, I am doing 1, 2, 3, 4, 5, 5 by 5 matrix. I am saying 5 cross. Okay, so A 0, A22, 0, 0, 0, 0, 0, A33, 0, 0, 0, 0, 0, 0, A44. You can see?
That should come before that.
What is that?
Before A44. It's coming in the 5th position.
Correct, na?
Then
5th. Oh, sorry. So one more 0. I made it 1, 2, 3, 4, 5. Oh, sorry. Yeah, I made a mistake, right? So this is good. A44, 0, then 0, 0, 0, 0, A55. Correct? Yeah, now it is correct. Am I right? So this is a diagonal matrix. This is an example for a diagonal matrix. Now you can understand clearly all the types and all. Okay? Row matrix means what you know. Column matrix means now you know why do we need a matrix first of all. Why the matrix is required to solve the problems. Okay, some of the when you have to deal with a group of numbers, and then we know what the definition of row matrix. Then we can make a column matrix, and you know why you have to make a column matrix. If you want to get some number out of from group of numbers, so you need to define a column matrix, and then we know what's a square matrix. Yeah, then we know what's a null matrix and diagonal matrix. And then finally there is something what they call as your scalar matrix. Actually, scalar matrix is again a see, now once you have a diagonal matrix, so what it says, diagonal matrix is only diagonal elements are non-zero, rest of all are non-zeros. Okay. Now if all these diagonal elements are same, for example, A of 1, 1 equal to A of 1, 2 equal to A of 3, equal to A of 4, 4 equal to A of 5, 5. Or say some number equal to 5 or 2. So then what happened? This is like 5, 5, 5, 5, 5. Right? So that matrix is a diagonal matrix, but all the diagonal elements are equal. You call that matrix as a scalar matrix. So the scalar matrix definition, how do you write it? Matrix. So first of all, so this will come for sure. A of ij is equal to 0 when I is not equal to j. Okay, and A of I equal to A of jj, I is not equal to j. We answered it, clear? This is the way. A of 1, 1. So if I take I equal to 1 and j equal to 2, so I is not equal to j. So A of 1, 1 should be equal to A of 2, 2. So it happens for all i's and j's. So that will become so this is what you call as a scalar matrix. And then we can go in one step further. And that is very, that is very interesting, and that is what you call, that's what you call as an identity matrix. You have to define that. Identity matrix, or they call unit matrix. Unit matrix. Okay. So this is basically again a diagonal matrix. It's basically this is from diagonal to you got it scalar. Scalar you will get into identity matrix where all diagonal elements are 1.
Okay.
You got it? So that means what? A of I equal to 1 and A of ij is equal to 0 when I is not equal to j. Correct? So that means this matrix will be identity matrix. The symbol they write it as I. Okay. So the symbol is usually defined as I. The identity matrix will be, and it's very interesting because am I right? I have done it? Correct? This will be 0, this is 1, and this is 1. Okay. And this matrix is I, and it's very, it's something like in your number. Okay. So if you take 2 minus 2, that is 0. Correct? So 2 divided by 2, 1. Okay. So the same thing comes here. So they same algebra. Something like you are, as I told you, remember I just showed you in your last class, I said that you will learn about the inverse of a matrix next year probably when you are 12th standard or whatever. So I said, so if A is a matrix, okay, if you remember, I'll repeat it. If A is a matrix, so we show this is a symbol of a matrix, and then P is a vector, this is a row matrix or whatever, that will give Q. Am I right? And then we said, suppose if you want to invert the problem, that means, then we said, that means A inverse minus 1 of Q will give you P. Now I'm asking what will be A matrix into A inverse matrix. It's something like 1 by A by A. Am I right? That should be ideally 1 for you. But here 1, if you can't define 1, again that has to be a matrix form. So that will be your identity matrix. And when you see, you define a matrix multiplication, it's very easy. You take any matrix A, any form, any matrix, but sorry, I would say not any matrix, square matrix, any square matrix. Okay, and bring equal same amount of identity matrix. You multiply with identity matrix, using the multiplication rule. What you will see is you'll get again as A. Okay, you can do that. So you construct any square matrix, multiply the square matrix the same order of identity matrix, you will still get back the same matrix. That means something like 2 into 1 equal to 2. The same way in the matrix we are saying some matrix multiplied by 1 equal to the same matrix. that 1 is the identity matrix. So 2 minus 2 equal to 0. The same way some matrix minus the same matrix should be equal to 0. That's what your null matrix. Okay, so these two, though looks very silly, they are very important matrices in order for you to define your whole problem. And why this different is because your orders, the matrix orders can be very different depending upon a different problem. As I told you, in your 2-dimension 2D geometry, only xy, there are only 2 elements. When you come to 3-dimension, it becomes xyz. So then if any null matrix coming there, then they will have order of 2 cross 2 or something like 2 cross 2 or 3 cross 3. And so that's what these definitions are important. Okay, so these types of matrix are important. Identity matrix. Is there anything left over for you? Yeah, then there's a very interesting thing. Triangular matrix. When you say triangular matrix, and let me try it here. Okay, see, this is matrix is a very important topic. And where will I write? I don't have space. Above one I will write? Oh, then I have to draw the write the matrix again. I'm very lazy to do that. Better let us keep that. Okay, so and the next one is the triangular matrix. Triangular matrix is very interesting. Wait. See, this matrix is when you go to higher classes, you will see this is a very important if you're going to do in your higher studies mathematics or physics and all, or even statistics and all. You will see matrix is a very important tool to solve most of your problem. Okay, and computationally also. Triangular matrices, there comes into 2 types. Triangular matrix is, suppose is again a square matrix. Okay, when I say square matrix, they both will be n cross n. Correct? Let me be. I don't want to make it simpler. So I don't want to write again matrix again and again. This will be what? N1, N2. Am I right? N3. Can you follow? Nn. Correct? So when it becomes Nn, now it's a square matrix. Correct? Oops, sorry. So and so possibly this line will come here. It should go up to here and then Ann. Diagonal, na? Okay, because this line, all the diagonal will fall into it. So now this is a square matrix of n by n, let us assume. If all the elements above the diagonal are 0, okay, or all the elements below the diagonal are 0, then you call that matrix as triangular matrix. So then triangular matrix gives you 2 types. Am I right? Above and below. So then what you call? So yeah, ideally with above triangular matrix, so what they call as a upper triangular matrix. Upper triangular matrix, and another one is lower triangular matrix. That's it. Lower triangular matrix. Okay. So that means what? It's simple. There's all the elements below it will be 0. Above will have a value. Okay. And in a lower triangular matrix, lower elements will be 0. Upper will be 0. Lower elements will have a non-zero elements.
What about the diagonal?
Only diagonal. That's a diagonal matrix.
What will be the value of the diagonal?
Oh, it can be anything. See, the point what I'm saying is, if this guy, so diagonal element can be anything, not to be equal. Any square matrix, take up any square matrix, if these elements are 0, then you call this as a lower triangular matrix. Okay, this is above the diagonal. Similarly, so this is not 0. So on the other hand, if these guys are 0, then you call only upper triangle is there, right? This is the upper triangular matrix. Okay. So actually, in matrix sort of most of the definitions are you can visualize also. What do they mean by that? Okay. So that's all you have Yeah. Then there are some more definitions. Shall we finish that one also? Yeah. So, and yeah, I guess that should come out to be later on. So, because I wanted to, yeah, let me do only two more definitions. They have introduced a determinant also. I don't know how to use a determinant now. Okay. So, let me do two more definitions and then I'll stop with the type of matrix. But still, we are not completed with the type of matrix. Still, there are many types are there. So, that I will do slowly. Okay, as we go further and further. So, now, eighth one is, so this is triangular matrix is done. And then what they have is a symmetric matrix. Yeah, see, these all are because when you do later on, when you do the most of the problems, these types of matrix will come into your life. When you are doing the real life problems, these are the types of matrix you will face, and you have a technique of how to solve them. See, that's why we are defining these matrices. These matrices, there are methods to solve this matrix. If your problem involves any of this type of matrix, then you can have a particular method by which you can solve that problem. So that's why these types of matrix has to be defined. Okay, another one what I said that is symmetric matrix. So I'll call this as 9. Oh, sorry. This is 8 now. Okay, 9, 10, whatever it is. Okay, fine. So let me call 9 and 10. So then 11th one is your symmetric matrix. See, symmetric matrix, see again by name itself. What happened? So if first this is A21, if A21 is equal to A12, okay, if they both are same. Similarly, A31 equal to A13, A32 equal to A23. Okay, so then such a matrix is called as a symmetric matrix. Tell me one example. For example, let me write down a matrix. Let us write a 3 cross 3 symmetric matrix. Okay, or 4 cross 4. Let us make it 4 cross 4. So tell me 4 cross 4 symmetric matrix. Tell me of any number. You tell me. 1, 3, 5, 7. No. What should be this element? Correct. Because they both should be symmetric. This can be anything. Not necessary. Diagonal can be any value. Okay. So this will be what? 2. Okay. I say 2. Whatever. 2 is just putting a number arbitrary. And then let us write any two numbers. What happened? 9 and minus 1. Minus 7. So then what this should be? Correct. 5. And what this should be?
9.
Correct. 9. Am I right? Because this 2. Right? And this can be any other number. So we let it because the diagonal element. Right? Diagonal element is minus 1. So, and then we put up any number. So what I will call it as 6. So now tell me what this number has to be.
7.
Are you sure? Yes, 7. And then minus 7. Correct. And then this is 6. And let this be any number, that will be 5. Let us put it any number. So now if you see, you have taken the diagonal element, I have taken separated out. Okay. So now you see the pattern. 3, 3, 3, 5, 7, 3, 5, 7, 9 minus 7, 9 minus 7, 6, 6. So this matrix is called as your symmetric matrix. In a symbolic form, how will you write? A of
Aij equal to Aj.
exactly. A of Ij is equal to A of Ji. Good. Okay, so this is what your symmetric matrix is. And then they have one more matrix, what they call the skew symmetric matrix. Skew symmetric matrix is simple. So with this definition, we will stop. Okay. So, and skew symmetric matrix. Or I think I will take one more definition. Skew symmetric simple. What you have said, the same thing. I just add a minus sign to it. You got it? So if it is minus sign, then that matrix is a skew symmetric matrix. Let us write down the same matrix in a skew symmetric matrix. All I have to first let me write down the diagonal elements. 1, 2, minus 1 and 5. Let me write down the upper triangular elements. This is what? 3
5,
and this is 5,
7,
7 and here it is 9
minus 7.
minus 7. So for this matrix, oops, sorry, here 6 is there, right? Fine. For this matrix to be skew symmetric, just opposite sign, right? So this will be minus 3,
Minus 5,
minus 5,
minus
minus 7,
minus 9,
here, right? Yeah, minus 9, 7, minus 6. So this is your skew symmetric matrix. Okay. Yeah, that's all. That's all. You have a skew symmetric matrix, and a singular matrix I will do later on. We already know the determinant. Correct. So then we will do the transpose. Okay, one more thing I will finish. With that I will stop. Okay. So I said I will stop and I continued 2-3 more definitions. You're able to follow, right? So, and see, matrix, it appears to be very simple, but see, most of your computer programs and all, advanced computer programs and all, what they basically do is they all solve matrix. Okay, so matrix is one of an important problem in life. How to solve the matrix. And what I said the last one is transpose of a matrix. Okay, this is not a type, actually it is a something, what the operation you do with a matrix. Transpose of a matrix. Do they have any other definitions you have? They don't have that. Yeah, you don't have that complex numbers till now. Maybe probably next year you will get it. Complex conjugate, all those things. Anyway, fine. Yeah. So transpose of a matrix is what? It is very simple. Convert your row to column and column to row. That's what your transpose of a matrix. Already we saw one. What is that? If you remember, we said that xy, right? x1, y1. This is a column matrix, right? Transpose of it will become just a row matrix. You got it? Because row becomes column and column becomes row. For example, let us take a matrix as something like, give me some numbers. 1, 3, 5, 7.
2, 4, 9.
You don't like minus numbers? Minus 8 and minus 9. Okay. So if I call this as A, and the transpose symbol is defined as A power T. Just convert the rows to column and column to row. Okay. So your first row will become first column. So that means 1, 3, 5, 7. Second row will become second column. 2, 4, minus 8, minus 9. Okay. Clear? That's what your transpose of a, yeah, there are two symbols. They can denote by A by T, they are writing. Always they call it as A, or they write it as A prime also. Okay. So, yeah, that's what. So, what in a symbolic form, if you want to write it as symbolic form, it looks like, suppose A is a matrix, and if my transpose matrix B, I call it as B, which is A transpose. So then the elements will be B. Okay. So then what happens? B of I comma J will be equal to A of J comma I. Just swapping it up. Okay. So that's all. I don't think so I have any other. Yeah. And this is the one interesting thing. So what will be the transpose of a symmetric matrix? It will be same, correct? So for a symmetric matrix, suppose if A is a symmetric matrix, if A is a symmetric matrix, A transpose will be A, correct? So what about for a skew symmetric matrix?
It cannot be seen.
Yeah, there will be only one minus sign, correct? The minus sign will get swapped. So for a skew symmetric matrix, so for example, if this I call it as B, then B transpose will be equal to minus of B. Just add minus with all the elements. Okay. Fine. I made a mistake. Sorry. I missed. Yeah, correct. For a skew symmetric matrix, your diagonal element has to be 0. Yeah. See, the sign has to be opposite, na? So, sorry. I made a mistake. You have to correct this. Huh? So, for skew symmetric, that's why I was wondering. I was thinking somewhere else I was doing a mistake. 0, 0, 0, 0. For a skew symmetric matrix, diagonal element will always 0. See, here everything minus and plus has to be equal, right? That comes only for 0. Okay, for everything else is correct. For skew symmetric matrix, remember, all diagonal elements has to be 0, and therefore, A of I should be equal to 0. This one. I missed it. That was a mistake. That's why I was wondering, because then only your A transpose will become minus B. Otherwise, this negative, this will have a negative sign. They will not be equal. Clear? Okay, so with that, I stop this class. Yeah, next we will try to go into more into matrix algebra. Okay.